In this video, we are going to look at a very important class of reactions, oxidation-reduction reactions. This word oxidation used to refer to the fact that these reactions often involve oxygen. Oxygen is a very reactive substance. It reacts with a lot of different things. If you take a look at the lecture slides, we looked at several of those reactions there. One of them was the reaction between titanium metal and oxygen in air to produce an ionic compound, titanium oxide. Now, I can tell that this is an ionic compound because I've got a metal and a nonmetal together. So we've talked about that before. We can tell what the charge on the oxygens in there are. If I look at the periodic table, I can see that there's a -2 charge on the oxygen. It's 2 jumps away from the nearest noble gas. It wants to pick up 2 electrons to become like the nearest noble gas. Everything in the oxygen column will form an ion with a -2 charge. There are 2 of them in there. It says O2, so there are 2 oxide ions in there. Now, if I look at where titanium is on the periodic table to try and figure out what its charge should be, it's in the transition metal section. And like I told you in class, you can't really tell the charge on an ion when it's in that section of the periodic table. So the periodic table doesn't help us much when we're trying to figure out charges for transition metal ions. But we can still figure out what the charge on the titanium should be. Now, if these 2 oxide ions in here have got a -2 charge each, there's a total -4 charge. And the titanium has got to be able to balance that. So the charge on titanium must be +4. So we have a titanium 4 ion in there. Now, in fact, this oxide is sometimes called titanium 4 oxide. All right, and we'll talk about naming things in a future worksheet. But back to this. What makes this reaction go? It's a pretty spectacular reaction. It produces brilliant white sparks, which are the flaming titanium chips that are being spit out of the sparkler. Now, if I look at the titanium before, it had no charge. If I look at the titanium after, it has a +4 charge. So it must have lost 4 electrons. I can write what happens to the titanium as its own reaction. It's titanium metal over here, and it turns into a titanium ion with a +4 charge. And it must have lost 4 electrons. I'm using E- as a symbol for electrons. This reaction is called an oxidation reaction. Now, if I look at what happens to the oxygen, I can write it like this. The O2 turns into 2 oxide ions, and it must be gaining a total of 4 electrons. Each oxygen atom gains 2 electrons, and then there are 2 of them, so it must be gaining 4 electrons. So 4 electrons are supplied to the O2, and it becomes 2 oxide ions. Notice that the amount of electrons that are produced, that are released by the titanium, are the amount that is absorbed by the oxygen here. So when I couple these 2 reactions together, if I add them together, they will give me this reaction. Now, this second reaction is called a reduction reaction, and that name comes from the charge. If you look at the charge on each oxygen atom in here, it's 0, and it goes to -2. So the charge is being reduced. So they call this a reduction reaction. When you put them both together, you get an oxidation-reduction reaction. This is sometimes called a redox reaction. So a little vocabulary there. Now, how can you keep these two straight so that if you saw these two half reactions, we call them half reactions because they're not the whole story. When you couple them together, you'll get the redox reaction. How can you tell which half reaction is an oxidation and which one is a reduction? Well, the oxidation always involves an increase in charge, while the reduction always involves a decrease in charge. So if the charge on something goes up, it's being oxidized. If the charge on something goes down, it's being reduced. So that's an easy way to think of it. Another way is, when you have an oxidation, electrons are being lost. When you have a reduction, electrons are being gained. This oxygen is gaining 4 electrons. Now you can keep that straight. If oxidation involves a loss of electrons, reduction involves a gain of electrons. So there's a mnemonic. There's something you can remember to keep straight which one is an oxidation and which one is a reduction. I will be asking you, is this a reduction or an oxidation? I'll be asking you, what gets oxidized? What gets reduced? If I asked you, in this reaction, what is being oxidized? Translate that question into, what has a charge that is increasing? Okay, this is increasing. It's going from 0 to +4. So this titanium is getting oxidized. And then if I asked you, what is being reduced in this reaction? If you look at the charge on the oxygen and it goes down to -2, that means the oxygen is being reduced. So you can tell oxidation from reduction fairly easily if only you can look at the charges on the atoms here. Now that's kind of difficult. I reasoned it out here, but we've got a job to do. We've got to figure out what the charges are in some of the products that form. Here it wasn't so bad because we had an ionic compound form, and we could look up the ion charges using the periodic table. And if we didn't know both of them, we could at least look one of them up and figure out what the other one was from that, what the other one had to be to make this an electrically neutral compound. But sometimes we'll be forming covalent compounds and they won't have ions in them at all. So how do I assign these charges to see where the electrons are going? Where are the electrons coming from and where do they go to? You need these numbers. And we're going to call these numbers not charges anymore, but we're going to call them oxidation numbers. And that will be the subject of the next 2 videos. We'll talk about how to get oxidation numbers in there. So if you didn't quite follow what I did right here, don't worry, we're going to go back to that and spend some time on that in the next 2 videos. Now what's important now is that we realize that there's an oxidation and a reduction coupled, and that there are electrons being transferred. The titanium is a source of electrons, and the oxygen soaks them up. It's a sink for electrons. So we can write a redox reaction involves transfer of electrons. Suppose I ask you on the test, define redox reaction. You would say it's a reaction that involves a transfer of electrons. That's the simple definition for it. So something has to give them up and something has to take them, soak them up. Let's do another one like this. Suppose I've got magnesium metal and it reacts with hydrochloric acid, HCl. That is going to give magnesium chloride and hydrogen gas. Now let's balance this before we go any further. We need to put a 2 there so that we have the same number of hydrogens on both sides and the same number of chlorines on both sides. Later on we're going to talk about writing out reactions like this. That will be the next chapter. For now, just take this reaction And let's look at it and understand why it is a redox reaction. There are two things going on there. One is that the magnesium metal, which has a charge of 0, is becoming a magnesium ion here, which from the periodic table has a +2 charge. So I can write that part of the process like this. Magnesium is becoming a magnesium ion. Get the charge from the periodic table. It's in the second column. Everything in the second column forms a +2 ion. Now, I must be losing 2 electrons. 2 electrons must be popping off for me to get that +2 charge. So there's the half reaction for that. Now ask yourself right now, is this an oxidation or is this a reduction? Now you should have said that it's an oxidation because the charge is going up. Now where's the reduction in this reaction? Because in a redox reaction you always have both oxidation and reductions happening. So let's see if we can write the reduction reaction here. Well, if I look at the chloride, if I look at this compound here, it's got a hydrogen ion and a chloride ion in there. And if I look at this compound, it's got a chloride ion over here. Now, it looks to me like the chloride doesn't really change charge going across, so it's not really participating in this reaction. But the hydrogen is changing charge, because here it has a +1 charge and here it has a 0 charge. So that's the reduction. I start out with 2 hydrogen ions, and that is going to an H2. Now where do I put the electrons in? With these reactions, the total charge on either side of the equation has to be the same. Here I have a total +2 charge. Here I have a 0 charge. What I have to do is put the electrons over here to balance the charge off. 2 electrons are absorbed by 2 hydrogen ions to produce an H2 molecule. This is the reduction reaction. And the two of these things are coupled together. So I want you to be able to do this. There are plenty of examples of this in the book, and in class I can work a few more if you want me to. Now let's introduce some terminology. You'll see these in the lecture slides. An oxidizing agent is a thing that causes oxidation to occur. This is the oxidation. What causes it to occur are the hydrogen ions. So these hydrogen ions are the oxidizing agent. An oxidizing agent is a reactant that causes oxidation. So we got 2 reactants here. You could either say the hydrogen ions cause the oxidation or the HCl causes the oxidation. You can recognize an oxidizing agent because it gets reduced. So that's what it is. It gets reduced. The thing that gets reduced is the oxidizing agent. This gets reduced because the charge on one of the hydrogens goes from +1 to 0. So that's a decrease in charge, so it's getting reduced. So that's the oxidizing agent in this reaction. Now another term that's complementary that they use is a reducing agent. That is a reactant that causes, guess, reduction. So, what do you think the reducing agent is in this reaction? What causes something to be reduced? Well, now the thing that gets reduced is this. What causes that to be reduced? It's the magnesium. It's got to be a reactant. It causes the H plus to be reduced to H2. So in this case, the magnesium. Now, why wouldn't you say the magnesium chloride or something like that? Well, look, it's got to be a reactant. So it has to be one of these two. It can't be that. It can't be a product that's an oxidizing agent or a reducing agent. All right, another way that you can recognize reducing agent is that it's the thing that gets oxidized. So, the thing that gets oxidized is the magnesium. It goes from charge of 0 to a charge of +2. All right, to be able to identify oxidizing agents and reducing agents, we are going to have to learn how to assign these charges that we have here. I assigned a +1 charge to the H. I assigned a +2 charge to the magnesium. Some cases we can do this using the periodic table, using the trends in ion charge that we have already talked about in lecture. But sometimes it's more difficult, and that's what the next two videos will be about, how we get the charges and set this up. Then in the final video, we will go back to using oxidation numbers to identify the oxidizing agent and the reducing agent in a chemical reaction.